Welcome everyone to today's webinar, Creating Scalable Microservices with OCI, Helidon, Jakarta NoSQL. My name is Nikki Chen. I'm a marketing event manager for the developer initiative here at Oracle. Today, we're excited to walk you through how developers can leverage OCI, Helidon, Jakarta NoSQL, and Oracle NoSQL to create scalable microservices. If you have any questions during the webinar, please drop them in the Q&A. We've also set up a Slack channel, Oracle NoSQL, in our developer workspace you can access at the QR code or at the link on the screen. This channel will remain open after the event for you to contact us directly whenever you have any questions. Before I pass it off to the presenters, I wanted to let you know we have some more amazing webinars just like this one coming up. You can check them out either with the QR code or the link in the channel. Okay. Today's webinar will be presented by Dario Vega and Otavio Santana, and Michael will be helping us with the questions. Without further ado, I'll pass it to Otavio.
Be here. My name is Otavio Santana, and today I will cover more about, how can I enhance my polyglot persistence with Oracle NoSQL database and Java. So it's a huge pleasure to come here and talk more about this and how to achieve that using Java with the newest specification, the Jakarta EU word, that is Jakarta NoSQL. So let's start. So as you might be familiar with NoSQL database and polyglot persistence, right now we do have a huge amount of flavors. So if you look in the perspective of 30, 45 years ago, we only had a single strategy of persistence, that is the relational database. That is, by the way, it's still super valid, it's still super important. I'm not complaining about relational database. Those are an amazing database. The point is, if you only know a single tool, you naturally will work to solve all the problems with this single tool. There is an amazing person called Maslow who had the instrument law. And he basically said that if you only know hammer, everything becomes a nail. Okay, so if I only know relational database, everything becomes relational database. And the point here is, as any software architecture, it produces trade-offs. That means the joint helps to consistency, to decrease the data. That makes sense. Mostly some time ago, if you remember, 1 terabyte was over $1 trillion. And of course, to avoid duplicated data. But right now, we are living in a different aspect of our society. Right now, it doesn't matter. It doesn't matter much. Of course, it matters the storage space, because it's become cheaper than 100 years ago. Right now, what matters is the time. So how can I reply quick as possible? And to make it possible, we do have several ways. For example, avoid normalization to make the data process and close each other to make a single request and return everything as a single response. Remember, joins are amazing techniques, but it has trade-off like everything. So to help on that engage in that journey, we do have NoSQL database to join you. So the idea is not to eliminate the relational database, but put more knowledge in your mind as you software engineer or software architect. This way you can operate with more diversity and solve more problems. So for example, here, we do have column family, graph, document, and key value. So those here are just sample of NoSQL database. Indeed, we have even more NoSQL database types. If you are new from relational database, please let me know. But in this relational database, we do have standards that makes our life easier to change NoSQL database, to learn a new NoSQL database, and so on. Sorry, to learn a new SQL database and so on. With NoSQL database, unfortunately, we don't have any kind of standard like this. And our definition by NoSQL goes by the structure and how this information will be saved in the database. That's why we do have those here, key value, document, and graph in column family, where key value, if you're a Java developer, looks like a map, or if you're a Python developer, like a dictionary. Then we do have column family, then document, where the structure looks like a JSON file or an XML file, and finally a graph database, where I can operate with multiple dimension of relationships. I mean, my relationship can have directions, can have properties, so I can go even deeper with graph than relation database. And right now, believe it or not, we do have over 200 NoSQL database. That means it's a huge amount of NoSQL database. That is great, but sometimes we do have a huge challenge, because how to handle a huge amount of NoSQL database that we do have right now? How can I make my life easier? Take here, for example, I do have 4 different NoSQL databases. Those are related to document. They're supposed to be similar on the way to structurize the information in the database. However, as you can see, every single database has your unique classes, unique methods. As you can see, ArunkDB has base document, MongoDB document, Couchbase, JSON object, ORNDB old document, and so on. But as you can see in yellow and red, they are trying to achieve the same goal. That is, insert information as document inside my database. So name, value, name, value, name, value, name, value for every single NoSQL database in the sample. And the question that might come for your mind is, if I want to achieve the same goal, why should I need to learn a new API every single time? Think about cognitive load for your organization. Think about the time to learn, to apply, to train the people just because we decide to switch between NoSQL database. And it's not exclusive of document, unfortunately. We do have even in around all the types. So if you take a look, for example, on key value database, that we do have Redis, React, Infinity, and no Oracle NoSQL database. As you can see here, I do have 4 NoSQL key value database that try to use a key value. If you remember what I said, key and value like a map or a dictionary, I still try to achieve the same goal. So key value, key value, key value for everybody. But for everybody, I need to learn a new API. I need to import different classes. I need to remember how it's works. And of course, it is not good for us. Why should I need to memorize every single thing if I want to achieve the same goal? Imagine right now, if you decide to have a new car, and then they decide to change the API. So right now, the accelerator is not on the right, but the middle or something else. It might be hard to take a new car, right? It might be hard to bring more people to this new technology. And that's why we are looking for new standards to make our life as a developer easier, to decrease our cognitive load, and of course, because as Java developer, we are seek for simplicity. And that's where I come from, Eclipse JNoSQL as a framework to make our life easier. And based on this framework was born the specification, actually 2 specifications that I come talk later. So as you can see right now, instead of need to learn different APIs to the same goal. Right now, what I'm doing is giving this document entity, I want to operate with ORMDB, ArongDB, MongoDB, and Couchbase. So write once and read everywhere. So we can use the Java logo or nickname for this, because with two different lines, with a single classes, that is document entity, I can storage in 4 different, or even more, in this sample 4, of course, 4 different databases. So ORMDB, ArongDB, MongoDB, and Couchbase. Right now at Eclipse JNoSQL, we do have support for 4 different NoSQL database types: column family or word column, graph, document, and key value. The goal is to increase the types of NoSQL database. And of course, it is based on the standard that I mentioned before. What Jakarta NoSQL stands for a new specification. So if you are not familiar with Jakarta, Jakarta is the former Java EE. That means everything that comes out from Java EE becomes Jakarta. That includes JPA, beam validation, CDI, Java server page, and so on. So it was the first Jakarta specification that was born Jakarta specification. We are using the proximity of the notation that we do have in JPA to NoSQL database, and based on that, I can say again, Aurora. I write once the annotations, the classes, and I can read it everywhere on the developer perspective. So I can read information from ArongDB, MongoDB, Couchbase, and so on, because I do have this couple of annotation. Of course, I'm talking about reading, but all the CRUD operation of database you can do with Jakarta NoSQL. If you're not familiar with CRUD, CRUD stands for create, retrieve, update, and delete. So the basic operation of any kind of database you can do with Jakarta NoSQL, thanks for these annotations. So we do have the template. It is like a skeleton to do basic operation with those database. And one important thing about NoSQL database is these particular behaviors, and that matters a lot for us. I mean, if you are using, or if you are looking for use Oracle NoSQL, for sure you want to use the capability of Oracle NoSQL, because it is amazing as a NoSQL database. You can use in the cloud, in the Oracle Cloud, you can use relational query with NoSQL database. You do have the capability of JSON and so on. So you can use this power with your particular behavior. So in this case here, I do have my templates, and then I start to working with a specialization. So document templates, and then I can do have the vendor template, as you can see here. So Couchbase templates, MongoDB template, ArongDB template, Oracle NoSQL template, and so on. As I mentioned before, Eclipse JNoSQL was born and then come out 2 specifications. One was super specifically to NoSQL database, but as you might know, as Java developer, there are several patterns that goes beyond the database itself. There are patterns that I can apply with NoSQL database, with SQL database, and naturally with new SQL database. And that's why we do have Jakarta Data. The main goal here is to simplicity, to make our life easier when talk about persistence layer and NoSQL database. Here in the sample that I can show to you, I do have my business in my regular business layer where I can coding, I can have fun, and then I do have the database access layer. So I guess you are familiar with now data access object. Can I use with NoSQL? Yes. Can I use with SQL? Yes. Can I use with any data representation such as web service? Yes, 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 and yes. And there is also repository that is a domain-centric way to handle with data. Let me see. Can I use with relational database? Yes. Can I use with NoSQL database? Yes. Can I use with any data representation like web service, whatever? Yes. So the main goal of Jakarta Data is to simplicity and make it a standard for the persistence layer that most of us, the Java world, and of course any language world, are working. So um, the goal here is, of course, have a common layer of persistence patterns with Jakarta data and two specializations. One that goes to relation database with JPA and another one that goes to NoSQL database that is Jakarta NoSQL. And that is a huge extensibility of Jakarta data because, as I said, the particular behavior matters when we talk about NoSQL database and, of course, SQL database. So here, I'm, of course, covering and going deep with SQL, NoSQL database, where I do have my data repository, my CRUD repository, my basic repository, and then I do have my specializations, like my provider specialization, around DB repository, MongoDB repository, Couchbase repository, and so on. And that is the beauty of the specification. I can make my life easier with that integration. Okay, so before show some code, I'll go quickly around the Eclipse JNoSQL components. So previously it was a unique monolith of code, and then it's become components. And right now we extract two components, one that is capable to work only with NoSQL database, that is Jakarta NoSQL. And then we do have Jakarta Data, of course, to work mostly with persistence layer at all. And based on that, we do have two layers. One to the mapping communication, where I will translate the annotation to the database, the driver, the communication with the NoSQL database, and the NoSQL, the official NoSQL provider. The main idea here is to avoid any kind of nightmare, headache, or reinvent the wheel. So I can use the same driver that the Oracle or any provider already has and make my life easier. And as you can see here, mostly of our components are driven by specification. So the developer, most of the time, will interact with NoSQL and data. If they wish to process JSON, they're gonna use JSON binding. If they want to use some injection points, dependency injection and so on, they can use CDI. And of course, every time that I talk about configuration in a database is super critical because the security and avoid any kind of data breach, especially in our code. And to make it possible, we can decrease the issues doing the 12-factor application, where that is the third condition that is about configuration, where you can send information and overwriting by system environment, and we can make it possible thanks for Eclipse configuration. So specification, 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 and now we do have a nuclear core that is going to do the translation, and that is it. So I will show some code here, and then of course Dario will come out with even more code. So first, let's go to the presentation mode. I enter the presentation mode here. So what I do have right now, I do have a really simple Helidon application. Okay, it's a Maven project. As you can see, I do have my dependencies. So it's a POM XML file with my dependencies. I put data faker to generate some random data. As you can see here, I do have my Helidon, dependencies, and so on. My whole configuration of Eclipse JNoSQL with Jakarta itself. Once Helidon implements microprofile, that means Helidon has CDI, JAX-RS, and JSON binding and Eclipse microprofile. So I don't need to handle anything like this. What I need to do is include the dependence that I need to do to work. So Eclipse JNoSQL database using and exploring Oracle NoSQL data. So it is my driver that I can make my life easier, and that is it. So I include my dependence, and then I go to my configuration. Here, I'm using local configuration, but as I mentioned, on production with container, you can and you must overwrite that configuration for make your life easier for you. So instead of doing that, you can overwrite. And on the real world, in the perfect world, you can put your code, your credentials on production if without nobody knows. Thanks for your system environment. And you can do exactly like this with Eclipse microprofile configuration. So we covered the properties, we covered the pennies. That's right now we basically the Jakarta provider or Eclipse microprofile provider plus the driver of Eclipse JNoSQL as I show. And then let's show a little bit more code. So for example, here I do have my beer empty. Yes. Where I have a single classic, I have several fields, and to make my life easier and do this communication, I can operate that with a couple of annotation. I'm gonna use nt to define nt here. I'm gonna use id to define the field that is an id. And I do have the column to identify 8 fields must go to the database and return to the database. Otherwise, the specification will ignore that field. So it is a little bit different from Jakarta persistence that by default, all the fields are persistable. Here, not. You need to explicitly say each field is persistable or not. Okay, so I do have my beer, the couple annotations. As you can see here, the main difference between SQL and NoSQL, I can have a list in a single place. So I'm defining my own structure with the fields that is pretty much like the JPA or Jakarta persistence. And then I do have my integration. That is basically a repository. So I created the repository interface. In this case, my beer repository. I extend from Oracle NoSQL repository. If you remember what I said, I can have multiple specialization like this one here. So Oracle extends my NoSQL repository. And naturally, the Oracle NoSQL is the one that I can use with more capabilities. For example, I can run my select star from user where status comes from that. And based on that, I can return users. So I can create SQL queries with Oracle NoSQL. How amazing is that? So for example, here, I'm doing the query by beer. And the last one that I will cover today is basically my beer. So I have my resource. I'm using plural because cup to domain, following the best practice of the global REST. And I just need to inject my beer repository. I'm done. So I did the whole integration with beer, and that is it. So I have my beer here that I'm returning the all beer that I do have, the beer by ID. Otherwise, I will return not found 404. And I will insert. On this case, I put the put method, so it will either insert or update. As you can see here, it's a save method. That means I don't even need to know about, okay, I'm inserting or I'm updating. So it belongs to the repository itself to check if the information is there. If it's there, it will update. If it's not there, it will insert. Of course, it will do one more process to check if the information is there by ID. And the last one is delete the information. Okay, so I cover quickly around the API, the documentation, the structure itself, the design that we did with Jakarta NoSQL, with Oracle NoSQL, and right now I'll give the spot for Dario to show this application running in the cloud. Dario, it's on you.
Okay, thank you. So currently what we have, so as we discussed with Octavio, we create a small GitHub repository that we call test Helidon. And I put here exactly the same program that Octavio showed. Then I did a clone in my cloud. So currently, for example, I am in this region, so I am in Ashburn. And as you can see here in my IDE, I have exactly the same application that Octavio showed. Okay, so we have the same VR class. We have the same VR repository using Oracle NoSQL repository. We have our VR resource, and we have our microprofiling config, our microprofile config properties. Okay, so as you can see here, I changed a little bit the original one. So just let me show you. So as you can see, here, Octavio was working in the local desktop. He was using a Docker image that we have for the Oracle NoSQL, so he already tested all the application. I just changed a little bit the port because I want to use a more standard port for HTTP, so that is 8080. And I keep the same value for the document and the key value database, so I have a table that I will call Olympus, okay? Then instead of going to localhost, I am saying I want to go to a region and I want to use a deployment. The deployment is, we will say that we will use the cloud, but when we are in the cloud, we have the possibility to use multiple ways to do the authentication. One of them is using API keys, but in this case, I need to manage and rotate the keys, okay? So for this demo, we will use something that we call instance principal. In this case, when we are deploying in our Kubernetes cluster, we are creating something that we call a dynamic group, and then we are providing the privilege to this dynamic group to create tables in Oracle NoSQL Cloud Service. So as you can see here, the next step was I create an Apple YAML application an Apple YAML file in order to deploy my application. And that is a standard YAML Docker Kubernetes file. The only modification that I did is that I put an image with the code that I generated in OCI registry. And I have some variables like Octavio told. In this case, I will say that I will use cloud distance principal. And for this use case, we will connect to Ashburn. So that is one of the regions that we are using. Okay. So I deployed this application using Kubernetes CTL. And as you can see here, it is running. My application name is Helidon, and it is running in this IP. So just let me test what happens if I try to execute our REST API, but it is not working. Why? Because currently I am deploying in a private network and I am trying to access from the public network. So in this case, what I want to use in order to do the communication is I want to use something that we call an API gateway. And in this case, the API gateway will be public interface, and it will be HTTPS. So I don't need to manage the certificates in my application because I will manage the certificate in my gateway. It's exactly the same thing for the security. I will manage the security in my API gateway instead of managing this in my code. So at the end, I will have, so just let me show you. When I start my application, this application creates an Oracle NoSQL that I will call Olympus. That is the name that we provided. And we create a table with the following structure. This is a table that we have an ID. We have a string that we call entity, and we have a content that we call JSON. So just let me do some queries here. And as you can see here, we have our beer and the contents for a beer. So we have the comments In my case, I add some other fields that we call the crew. Okay, so that is Otavio. We have some data, and we have all the information that we have in our class, in our entity that we call beer. Of course, if you are saving more entities, in this case, we are using the same table, so the same Olympus table. So I am storing all the information for all my entities in my Olympus table. Another interesting thing is when I am deploying using Oracle NoSQL database, we have the possibility to have what we call read capacity and write capacity. So it means that for this application, we are saying, okay, in order to do for this application in Ashburn, I am expecting 1,000 reads and 1,000 writes. And of course, I can change every time that I need, and I can use on-demand capacity. So what we did with Mike is we know very well what is the profiles of our users that are in Ashburn. So we know that at this moment, we need this read capacity, this write capacity. We test already what happened with on-demand provisioning, because that is the other solution. And we decide that the best for us is to use provisioned capacity. Okay, so when I run my application, so I run my REST API, now I will use my API gateway URL, and I will execute beers. And as you can see here, I have my beer, so I have my catalog. The problem is that I am in Paris, and my gateway is in Ashburn. Okay, so now we will implement. So now our society decide to have clients, customers in Europe. So we are trying to see what is the workload in Europe, because it is different than the workload that we have in USA. So that the workload that we deploy in Ashburn. Okay, but the first test that we did is when we are in a vantage point. So we are executing for multiple sites. We realize that we don't have the same performance if we are in Europe and we are in USA, and of course this is because of the latency. So what we want to do with Mike is to deploy the same application, but this time we will deploy the same application in Paris. So I will show you what we did. So our first test is I will go to Paris. As you can see, I deploy exactly the same application. So I am here, Olympus. Now, when I am executing, I have only one beer in my catalog of beers. So that is the Cascade beer. Okay. I set up all my application, and when I am running, of course, I have my beer. In this case, I have only one beer for Paris. So if you look here, in this case, for Paris, I have only 10 read units. I have only 10 write units. And I have, unfortunately, I forgot, but I forgot to create the index for performance. So if you go here to Ashburn, I will have an index for performance. Okay. Let me go to Paris again. Now my challenge is that I want to have the same data in both regions. Okay. So I want to, when I am querying the data in Ashburn, I will have the same data that I have when I am executing in Paris. Okay. How to deal with this? So currently, I don't need to change my program. I just need to configure what we call a global active table. So in order to do this, I will go to Paris. I will go to my Olympus table, and I will delete this table. So it is deleted. Now I will go to Ashburn. I will go to my Olympus table. And I will say that I want to add a replica. So remember, I have an index. I have a read capacity unit of 100. I have a write capacity of 100, and I have a disk storage of 5. Okay, and I have an index. So I will create what we call a replica. So the only thing that I need to do is I need to choose where. So as you can see here, we have all the regions available, and I will look for Paris. So now I have Paris. And of course, I will change the read capacity because in my case, I have less customers in Europe, so I need less capacity for my application. Of course, I did the same thing for my Kubernetes cluster. I did the same thing for my load balancers. I did the same thing for everything. The only thing that I cannot change is the disk storage because I am expecting to have the same data in both sides. So we are guaranteed that we have the same disk storage in both sides. So just let me click in Add Replica. So we will create our first replica. So I just need to wait a little bit. Replicas. This is a good demo. Oh, I click or I forgot to click. Let me go to Paris to validate what's happening in Paris. Okay. So anyway, it was a refresh problem. Okay, so just let me see. So as you can see here, now I have the replica here. I am saying that I am in Paris and I have a replica in Ashburn. Of course, if I go to Ashburn, I will say the opposite. So if he wants to work. So I will see the opposite. So if I go to Olympus replicas, I will say that I have a replica in Paris. What happens if I execute again my application here? I will have exactly the same data that I have in Ashburn, in Paris. And every time that I'm modifying something in Paris, I will modify the same thing in Ashburn. And every time that I am adding a new element, a new beer in Ashburn, I will have automatically the same data in Paris. So that is what we call a geo-distributed application, because as you can see here, we have exactly the same data in Paris, and we have exactly the same data in Ashburn. And the interesting thing is that I have the possibility to have read units, write units that are different for my application in Ashburn and my application in Paris. Why this matters? Because currently, for example, if I have a new region, for example, I don't know, Africa or Oceania or Japan or something else, I can share my catalog. But when I am doing my capacity planning, I don't need to change my capacity planning for Europe. I don't need to change my capacity planning for Ashburn. And by the way, from a chargeback perspective, I am able to say how exactly I am depending. I don't know. I am polyglot, so I speak French, I speak Spanish, and sometimes I have problems with the words. But that is what I want to show you. So if we want to now go to another region, for example, Mumbai, we can say in Mumbai we are expecting a little bit less, but more than in Europe. And I can create my new replica in Mumbai. Okay, so I will work here. And in the waiting for this, I will go again to Paris. And the interesting thing is if I click in indexes, I have exactly the same indexes that I have in all regions. If I add a new index for a new performance because we are doing a different query or a different pattern, or because we are putting another entity inside our application, so I will be able to create another index in order to do the performance. Okay, let me go to Mumbai. So in Mumbai, we have the same application. If I try to explore the data, I will have exactly the same data that we have in all the regions. The only thing that I need to wait is the local replica initialization complete 100, because if I have a lot of data, of course, when I am initializing my replication, I need to copy the data from Ashburn or from Paris to the new region. Of course, my recommendation is to try to do the replication between two regions that are more closet. Okay. So now that we are happy with this, I just want to show you other things. So as I told you, I create what we call an API gateway. So let me show you what is an API gateway. So here in Paris, I have two APIs gateway, and I have one that I call demo events. So in these demo events, I will go what we call a deployment, and I will see what I deploy when I am using our test Helidon. If you edit, so here we have multiple possibility. We have the possibility to work our course, do a writing limit, have our login policy to follow up what we are doing. When we are doing the authentication, we can say no authentication, or we can do a single authentication using OAuth2 or authorization function. We can use GW token, etc., and we can have a multi-authentication. So if you are a developer, it is really interesting because you are just creating, how to say, a REST API on HTTP, and everything that you need to manage, like course, like certificates, like authentication, you can say, okay, I will put this to my API gateway. Okay, in my case, I am using no authentication, and then I am just saying that everything that arrives to my gateway, I will route to our deployment. If you remember, that is the load balancer for our Kubernetes deployment. So now, just let me show again. So if you remember, when we are doing the get services, here we have the external IP of our load balancer. If you remember, when I try to contact, it doesn't work because I was in the public network. And now, using this, I am using exactly the same address, but in this case, I am able to access this address. Okay, so that is a kind of demilitarized zone. So just let me do a cancel. Another interesting thing that we have for a gateway is, in this case, I have a public IP. So I can use the public IP or I can use the host name. Of course, in this case, I need to use the host name because my certificate is based on the host name, okay? So now let me show you another service that we have in Oracle Cloud Infrastructure in the networking that we call the traffic management steering. So I will create what we call a traffic management experience. So in this case, I will say that I will use a geolocation steering. Of course, here we are using OCI, but you can use the same thing with your DNS. Okay, so I will call this test. At the end, I will not execute, but I will say that I will create a answer pool name. For example, in this case, I will call this Europe. forget, but here I will put my address. I will create another pool that I will call USA. Well, here I will not provide the name. And then I will create what we call the geolocation steering rules. So for example, I can say, okay, I want to use North America, or for example, I can use the rules with countries. And for some countries, I have the possibility to use regions. Okay, so for example, for USA, we have regions, and I can say, does states go, for example, to Ashburn, and other states go to Phoenix or San Jose? Okay, so I can do this kind of things. I will do something simple. I will say, well, we have a lot of things. So I will say North America, and I will select my pool. So I will say my priority is when someone is located in North America, I will go to USA. In our case, we will redirect to an application that is running in Ashburn. Otherwise, I will go to Europe. I can add another rule, and I can say for the people in Europe, I will go in priority to my pool in Europe and USA. And I can say, if, for example, someone's arrived from Latin America, I can say, okay, if coming for South America, I will go to USA and instead of Europe. Of course, if I decide to deploy, for example, in Sao Paulo, I can change my rules, and now all the people in South America will redirect it to Sao Paulo. I don't know where are you come, Otavio? Are you come from Sao Paulo? Are you come from Rio? I don't know.
Almost Salvador.
Salvador de Bahia. Okay.
Yes.
That's good. Okay, that's cool. And then we will create our policy. And of course, now if we access, for example, using our NDCS, for example, I will call NDCS minus Dario Enterprise. Instead of using this URL, I will use another URL, and this URL I will redirect using the DNS geo-steering traffic. So I finished for today. I just want to show you a last example here is, for example, in my case, I create a NoSQL example directory. And in this directory, I have a GitHub workflow. And in this case, as you can see here, I am deploying everything using a GitHub action, using a deployment, a workflow from GitHub. Of course, if you are using OCI DevOps, or if you are using GitLab, or if you are using other DevOps tools, you can do the same thing. I don't know if we have questions. I will stop for today.
Yeah, that's nice. I mean, one thing that I enjoy a lot around the Oracle NoSQL is because it implements the concept of database as a service. Me as a developer, I don't need to go deep on configuration, properties, environment, or anything like this. It is ready for me. And I really enjoy that.
I will share this because that is an interesting comment. So, sorry, stop. I'm not sharing the code. Just let me show you something. Here, for example, when if I decide to go to India and I go to our NoSQL tables, so today it is slow for me. So as you can see here, I am not creating any cluster. I am not deploying any infrastructure. I am just saying I want to create a table, and that's all that I need. But behind the scenes, if you go, for example, to Ashburn, we will go to the table created by Jakarta NoSQL, so our table Olympus, because we have some time. I have some metadata. So for example, I just want to share this one with you. So as you can see here, it is sharded. So that is a distributed database. It is sharded, and I can have access to the shard here, okay? I know that this row is in the shard 1. I know that this row is in the shard 2. How many shards I have behind the scene? I have no idea, okay? I just know that my cluster is distributed. Everything that I am inserting a row, for example, here we are in Ashburn. In Ashburn, we have 3 data centers that we call availability domain. So we have availability domain 1, availability domain 2, availability domain 3. Every time that we are inserting using Jakarta NoSQL, we are inserting in the 3 data centers, okay? Who is the master? Who is the replica? We don't know, but we know that our service is high availability, and this is why we are writing in multiple availability domains in this case. Another thing that is interesting is we have something that we call an expiration date, and in fact, we call this time to live in days. Okay, here I am saying that we have 5 days. Okay, it means that this data will automatically purge it after 5 days. Okay, in this case, when we started, I told that all of those data don't expire because that is my demo. Okay, so I did, but I remember, I don't know if you can tell more, Octavio. I think that we implemented the time to live with Jakarta NoSQL because you have this possibility. Can you tell more?
Yes. But before say that, you mentioned about, okay, I don't need to know about that. Indeed, I don't care. I know there is someone who do it better than I. It's like magic. So for me, it's a beauty of cloud, right? It's somebody else's problem. So I can have high scalability of database. I can have distributed database, and it's a service. It's a knowledge data service. I don't to go deep in anything like this. I know it is working, and I'm totally fine with that. About NoSQL, Jakarta NoSQL integration like this is working super smoothly. So we are working in the release of Jakarta Data specification that brings more capabilities and resource. For example, 2 ways to do paginations. So the offset, the most popular one. However, it is not optimized like the cursor one. And this one that we are working for. And we do have Jakarta Data query language and so on. So more features, more capabilities is coming in this next Jakarta Data version.
Okay, Mike, are you here? Can you hear me, Mike?
Yes.
Can you explain a little bit more what means reserve capacity, provisioned capacity, on-demand capacity, please?
Sure. So within the Oracle NoSQL Database Cloud Service, we have 2 types of capacity, provisioned and on-demand. Provisioned capacity is the least expensive of the 2. And with the provision capacity, you as the customer of the service, you make the decisions as to what you want your capacities to be. These can be dynamically changed either up or down via a program or via the console as it is being shown up here on the screen. For the on-demand capacity, we as the system owners, we will make the adjustments for you on your behalf, and then we will dynamically grow both your read and your write capacity. We will also dynamically shrink your read and your write capacity based upon the needs of the application on a second by second basis. Because we, the service owners, are making that determination, and we have some AI that's involved to do that, then the cost for the on-demand capacity is more than the provision capacity.
Okay.
And
something else?
nope, that basically covers it.
Okay, so I just want to click here and I will say now that I have 10 gigabytes, so just for information here, I am changing the capacity for all the replicas that we have. I don't know if we have more questions in the chat, so otherwise up to you, Nikki.
If you like today's session, we'd love to invite you back to check out our upcoming events. With that, I'll go ahead and end today's session. Have a good day and hope to see you soon at our future events.